Hello everyone, my name is Emrah Şirin. Me and my friend Furkan will make a presentation about performance and durability of concrete structures in railway environment under extreme climate. This presentation is a summary of a paper which is written by Lei Wu and Sakdirat Kaewunruen in 2017. The scope of the paper is to analyze the effect of climate change on the performance and durability of concrete structures based on a number of experimental and field data. Another objective of this paper adopt statistical analysis for estimating the effect of increasing carbon dioxide concentrations and global warming induced changes in temperature and humidity on the durability of concrete structures. So what is an extreme climate for concrete? The term extreme climate has been applied to situations where the average condition of the weather event is severe or extreme weather events occur during this period successively. It is also defined as statistical theory that extreme events are either low frequency of occurrence, which refers to threshold with 10% of values lower and 90% of value higher. This definition of extreme can be seen on the figure on the right side. So what are the effects of the climate change, the extreme climate? According to IPCC, the climate changes tend to increase the average temperature of the world. As the temperature increases, the carbon dioxide concentration in the atmosphere will increase too. The increase of carbon dioxide concentration in the atmosphere will make carbonation rate of concrete accelerated, and the corrosion in the steel bar in concrete, in reinforced concretes. So the top figure shows that the climate change made the weather hot. It is more likely to record hot weather than cold weather around the world. For example, the bottom figure shows the temperature distribution in Beijing, China for previous and new climate. The dotted one is new climate, obviously, and it is more hot than the previous climate. High temperature also can influence the performance of concrete. 3 concrete test series using different water cement ratios, concrete A, concrete B and concrete C, used to test the performance of concrete in high temperature, and pointed out that as the temperature increased from 20 to 100 degrees, there is a very small increase in the compressive strength. After that, the value of compressive strength shows the decline with the temperature increases. Here's the figure of the experiment I just told you. This change of property of concrete material under high temperature is mainly due to the evaporation of water in concrete. Also the property changing of aggregate and cement materials. The bond strength between cement and aggregates also reduces under high temperature. However, concrete can reach maximum 80-90 degrees even when atmospheric temperature reaches the 45 degrees. So it is almost impossible for concrete to reach these high temperatures. The concrete can keep its compressive strength under high temperatures, but high temperatures can influence the flexure strength dramatically as shown in the figure. In addition to high temperature, the low temperature also can result in cracks. In a cold climate, any water which permeates the concrete surface through the concrete's pores will be frozen. As it freezes, it expands by 9%, thereby increasing pressure in concrete. According to Solatian, if the resulting stress is greater than the intrinsic tensile strength of concrete, reinforced concrete, a crack will occur. This process is called freeze-thaw cycle. And the concrete permeables were exposed to the temperature of 20 degrees below zero, simulating a freeze-thaw situation. Freeze-thaw cycles can influence the properties of concrete significantly. The experimental data on the right shows that all of the statistical strength of the concrete, which are compressive, tensile and fractional strengths, will decrease when the number of freeze-thaw cycles increases. So from now on, I will hand it to my friend Furkan. He will continue to present the presentation.
Hello, my name is Muhammet Furkan Baytar. The impact of cycles. Beside the effect of single extreme climate, the combined effect of extreme weather will be more serious. For example, after high precipitation, the concrete will suffer from heavy insulation. This process can enable the internal water of concrete to undergo two physical processes, referring to the amount of absorption and evaporation respectively. Concrete meets the process of drying bedding cycle, which means its internal relative humidity goes from low to high. And then from the high to low process of humidity levels, as a consequence, the effects of this process are more severe rather than single extreme climate effect. Chemical effects of climate on concrete. There are two different types of chemical processes owing to external environment, which would after which would affect the durability of concrete structures. One is carbonation of concrete and another is chloride penetration. The external environment of concrete, such as high temperature and floods, would increase the potential of corrosion of the reinforcement. Once steel reinforcement undergoes corrosion, the properties of the whole of the concrete structure will be affected in the terms of durability. With the intensification of corrosion, the process of deterioration will be serious, even resulting in collapse. High strength concrete, fiber reinforced concrete, self consolidation concrete, and fly ash concrete were tested 20 degrees and 800 degrees. The data from experiments of Kalik and Kudur also are plotted in the section. The four specimens with different mixed fly ash were heated during 20 degrees to 800 degrees. Data generated from these tests are used to drawing the trend line of splitting tensile strength at elevated temperature. According to average of relative residual splitting tensile strength on every temperature, the mean trend line can be drawn. It can be seen from figure that the strength properties of splitting tensile strength after heat decrease with temperature increasing. Additionally, the high performance concrete, drop fast and self-consolidation concrete show the gradual reduction in terms of properties of splitting tensile strength after heat. Carbonation depth and temperature relation. This graph shows that the carbonation depth increases with the temperature and therefore reduces the durability of concrete. So it can easily be said that the high temperature is not good for concrete structures. Conclusion, it's possible to claim that the change of climate has different impacts on the mechanical property and durability of concrete structures. Results show that extreme high temperature could not impact the compressive strength and tensile strength. Extreme high temperature could dramatically impact the flexural strength. In addition, if structure of S1, S2, and S3 class exposed environment of exposure of XC1 class, these structures could easy to undergo the carbonation and corrosion of steel with high temperature and high carbon dioxide concentration. Thank you for listening.